Hello everybody. Today I would like to give a talk on smart logging, an innovative approach for generation of digital subsurface data. My name is Anthony So from the Development Bureau, and he's the co-author of this paper. Tony Ho is also from the Development Bureau, and Louis Wong from the Earth Science Department of HKIE. Collection of subsurface data is one of the crucial parts of construction projects. Nowadays, with the rapid development of digital technology, many engineers make use of 3D and BIM applications to facilitate their work. As you all know, ground investigation is to obtain reliable information to produce an economic and safe design and to meet tender construction requirements. Here's an example of a hard copy GI log. In the final GI fieldwork report, in addition to the hard copy report, there's also an AGS disk. AGS data format is published by the Association of Geotechnical and Geoenvironmental Specialists, UK. AGS disk has become one of the contract requirements in GI term contracts since 1993. And most government contracts have also include similar requirements for AGS data. Here's an example of AGS data. Do they look like secret code? But in fact, if you save it in CSV format, you can open it in Excel, and you can see the GI information like borehole number, sample top, and sample base, and the data become more user-friendly. All AGS data received are kept in GIU of the CEDD, each with a unique GIU number. All AGS data are transferred from this to a server in GIU, and currently over 210,000 GI data in AGS format. The AGS data, including the GI data, including AGS data, can be retrieved from the G-info. It's just a matter of pressing a few buttons. You can download this data. The AGS data can then be used to establish 3D geological model using various software packages. However, there are issues on generation of these data, and I believe many of you are aware of. Borehole data such as geological log, field test results are recorded manually and in hard copy format. During production of GI report, each such record needs to be transferred to digital format, and such work involves substantial resources and time, and sometimes may introduce unnecessary error during data transfer. And normally, it takes some time after completion of field work before project engineer or engineering geologist can obtain the GI log, which is not desirable, especially most construction projects have very tight schedule. To tackle above issue, smart logging approach is proposed. In this approach, we use mobile device to generate geological logs in a real-time manner. Let me explain the principle of this approach. All existing GI data can be retrieved from the G-info. Project engineer can use the existing data to form preliminary ground model before ordering GI. Geologists and site staff use mobile handheld device to input geological and other GI data. And these data are then uploaded to the server or cloud. And at the same time, project engineer can download the data to refine the geological model. If the GI data are not sufficient, they can order additional GI immediately or finalize the ground model if the data are sufficient. It is an example of the smart logging app. Here are the existing borehole from G-info, and DH1 and 5 are new borehole using smart logging app. The additional borehole can be used to correlate with the existing borehole data to refine the geological model. A feasibility study to test the functionality and practicality of the smart logging approach has been carried out. A beta version of the smart logging app has been prepared. This app can be run on two most common mobile operating systems, iOS and Android, and promising results were obtained. Smart logging approach is proved to have great potential to expedite the generation of digital GI data and geological model. Here's what the beta version of smart logging app looks like. On the left, there's basic information, and the geological information is on the right. In this app, there's also a button to convert the data to AGS format. To further evaluate the practicality of the proposed approach under actual working environment, pilot contract will commence. A full version of the smart logging app, which is capable of recording geological description, field test result, and field installation, will be developed. In addition to the logging by the geologists and other field personnel, HKIE have recently used deep learning model to classify common rock type in Hong Kong. The aim is to develop a mobile app for automatic classification of common rock type, decomposition grade, or determination of fracture state index based on core box photo. And this mobile application can become a module of smart logging to provide a useful check of the GI log done by the field personnel to reduce human error in the future. Here are some results of Hong Kong U, and the results are promising. It is the end of my presentation. We conclude that smart logging approach can provide a convenience, effective and efficient means to generate digital subsurface information to facilitate construction projects. AI tools have recently been developed and can be integrated into the smart logging app. Although this subject still remains challenging, it is believed that technical problems arising will be resolved and site personnel will gradually adapt to this approach. Thank you.